Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 11.2 entitled Direct and Inverse Variation. And today we're going to talk about how you can write and solve direct and inverse variation equations, and then we're also going to graph direct and inverse functions. Now we've talked about direct variation before, and it's when there's a relationship that directly relates to variables, like the number of hours you work and how much you get paid for working that total number of hours. So the constant that relates both of those is how much you get paid per hour. So that's why we have this equation here, y equals k times x. So x and y are the two variables that have a relationship, a directly related relationship, and k is the constant that relates them. And then inverse variation, that's where there's another relationship between the two variables, x and y, except this time if you take your constant and divide by x, then you get the relationship that relates x and y. And when we graph these, they look very, very different. So aside from one being multiplication and one being division, they also look different. Direct variation is going to be linear, and then inverse variation, whoops, actually, let me fix that graph, because direct variation always goes through 0, 0. It always goes to the origin. Okay, so it's going to be linear. It's going to go through the origin. And then inverse variations, their graphs are more swoopy, I guess is a way to call them. They have more curves. So there's a curve there, and then there's a curve there. And those curves are kind of like exponential growth or decay curves. And there's going to be one in the first quadrant and one in the third quadrant. Or there could be one in the second and one in the fourth. So the difference between them is that direct is where we multiply. And then inverse variation is where we are going to divide. That's the main difference between them. So if we look at our first example here, you're going to see some problems like this in your homework as well, where they just want you to figure out if you have an inverse or a direct relationship between the variables in the equation. So for part A, we have y equals 4 divided by x, and since we're dividing by the variable, that's going to be inverse variation. You can divide by a number, that's okay. That's not necessarily inverse variation. But if you're dividing by the variable, that makes it inverse variation. Part B, we have y equals 4 times x, and since there's multiplication going on there, that's going to be direct. And this would be very similar to y equals mx plus b, y equals 4x plus 0. If we added on that 0 at the end, the 4 is going to be our slope, and the 0 would be our intercept. So again, it's always going to go through the origin, 0, 0. For part C, we are given the equation y equals 1/4 x, and there's really 1/4 times x going on here. The multiplication is the operation that's between the number and the variable. So again, since there's multiplication, that's going to be direct. And sometimes students say, oh, but it's division. So then I say, well, we could rewrite that. We could rewrite that as 1x over 4 to show you that if we multiply it across, we can put the x over 1. And if we multiply it across the numerators, 1 times x is 1x, and 4 times 1 is 4. So we're dividing by a number. We're not dividing by the variable. So since we're multiplying the 1/4 and the x, that's direct. And you could also think of that as your slope. Y equals 1/4 x plus 0. That 1/4 would be your slope. Now for part D, this is a tricky one. This is about as tricky as it gets. Here we have x times y equals 1/4. And if we're going to have our variation equations, they have to be solved for y. So what I would do here is I would divide by x, or I would multiply by the reciprocal, which is 1 over x. So I'm going to think of it that way. If I multiplied both sides by 1 over x, then I would get y equals 1 over 4x. And then I have my variable in the denominator. Now the number's okay in the denominator. That 4 doesn't really matter. But since we're dealing with an x here, when we have 1 divided by x, since that x is in the denominator, that's going to be an inverse variation. So the point of this example is that there's lots of different forms that these equations can be in. But if there's multiplication between the variable and a number, that's direct variation. And if there's any time where you're dividing by a variable, then that's inverse variation. Okay, now in our next example, we're told that our variables vary directly. The variables x and y vary directly. So now we're told that we have to use the y equals k times x equation, because that's the equation for direct variation. And that's the equation that we saw earlier in the year as well. So we're going to use the given values to write an equation that relates x and y. So I'm going to start by taking my equation, y equals k times x, and I'm going to substitute in the values that they gave me. 20 goes in for y, the k stays k, and the 4 goes in for the x. And then if I'm going to solve for k, I need to divide both sides by 4. So 5 is my value for k. And now I can write an equation that relates those two variables. Y equals 5 times x. So that would be the equation that they want for our answer. So since there's a direct relationship between x and y, you would take whatever x is and multiply it by 5, and that would give you y. So x could be the number of hours that you work, and 5 could be the amount of dollars that you get paid for every hour, and then y would be your total salary. Okay, for part B, we'll do the same thing. I'll start with y equals k times x. Here y is 49, and 7 goes in for x. The k stays k. And then I'm going to divide by the 7 because it's the number that's with the k, and I'm trying to solve for k. So here I'll get k equals 7. And it's 7 because 49 divided by 7 is 7, not because this x was 7. So then my equation will be y equals 7 times x. Okay, and then the last one, this is just to make you think here, y equals k times x, again, is what we're going to start with. But if you notice so far, we've had the larger number for y, for example A, and for example B. Now our larger number is for x. So y is going to be 6, and k is going to be k, x will be 18. Now a lot of times when students see this problem, they think, oh, 18 divided by 6 is 3. But that's not really what we want to do here to solve for k. We want to divide by 18. So my value for k is going to be a fraction. It's going to be 6 over 18, which I can reduce to 1/3. So my equation will be y equals 1/3 x. And that might be a relationship of like how many fish are in a lake before and after fishing season. Maybe x is the amount of fish ahead of time. 1/3 is how much of the fish get caught by all the people fishing, and then y would be the amount afterwards. So this would be some kind of more of like a decrease type of relationship. So the point is that you don't always divide the bigger number by the smaller number. Okay, we did in example A and example B, but in example C, pay attention because here we're dividing the smaller number by the bigger number and we get a fraction for our answer. Okay, now in example 3, here are the variables x and y vary inversely, so we're going to use y equals k divided by x for our equation. And then again, we're going to use the given values to write the equation. So I'll start with y equals k divided by x. And y is going to be 4 when I substitute it in. K stays k. X gets replaced with 3. And then again, I'm solving for k, so I have to times by 3. So k will be equal to 12. And then I'm going to rewrite my equation. Y equals 12 divided by x. So notice here, we're taking 4 and 3, the values for x and y, and we're multiplying them together. And that got us our value for k. So let's see if that happens again here for part B. And y equals k divided by x is the equation that I'm using. Y is going to be 2. K stays k. X gets substituted by 8. And again, to solve for k, I have to multiply both sides by 8. So 16 will be k. So again, I was able to multiply my values for x and y together to get my value for k. So y equals 16 divided by x. That'll be my equation. Now for part C, this one's a little more challenging because we have a decimal, but it's the same process. Y equals k divided by x. Y is going to be 50. K stays k. X will be 1.5. And again, if I'm solving for k, I have to multiply both sides of the equation by 1.5. So again, I'm multiplying my values for x and y together so that I can get k. And that only happens when we're solving our inverse variation equation. Now 50 times 1.5, that's 75. That should happen when you multiply by a decimal that's bigger than 1. You get a bigger answer there. So y equals 75 divided by x. That's the equation that I'll use. So when you're solving your inverse variation equations for k, for that constant, you will be multiplying your values of x and y together. Not that I want you to just do that directly, but that's a good observation to know, so that way you can know that you're doing the problem right and that you're getting the correct answer. Okay, now for example 4 and then example 5. Oh, I'm sorry, just for example 4, we're going to be graphing. Now we are going to make our table of values, and here we want the table of values to go from -4 to +4. So that's how it is for this example here. It might be like that in your book as well. We just want to make sure that we have plenty of negative and plenty of positive values when we're graphing these equations. That's the whole point of that. So you don't always have to go from -4 to +4. We just want to have some negatives and some positives. And then we're going to say whether or not the equation is direct or inverse. Now we can probably state that just by looking at the equation. For part A here, we have 2 times x, so we're multiplying the constant and the x variable. So this is going to be a direct variation equation. And here for part B, we have y equals 4 divided by x. So since we're dividing by that variable, this is going to be inverse. So now for part A, if we go and complete our table of values, we're just going to substitute the values for x into the equation and get our value for y. So -4 times 2 will be 8. -3 times 2 is -6. -2 times 2, that's -4. -1 times 2, that's -2. Then we'll have 0, and then 2, 4, and then 6, and then 8. Okay? So when I plot those points then, let me scooch down a little bit. I went to -4, 1, 2, 3, 4, and then -8. And then we had -3, -6, -2, -4, -1, -2, 0, 0. Remember, all direct variation equations are going to go through 0, 0. And again, that value that's in front of the number, in this case it was a 2, that's kind of like our slope. So again, we could write the equation y equals 2x plus 0. So this 2 value is going to be our slope. And then this 0 at the end, that's going to be our value for b. So that's our intercept, 0, 0. And then our slope is going to be 2, or 2 over 1. So you can see that that's a connection there between how we've been graphing before. We're starting at 0, 0, and we're going up 2 and over 1, up 2 and over 1, up 2 and over 1. And since this is a straight line, It's a linear relationship. It goes through the origin. Again, that's all confirmation that it's a direct variation relationship. Now for example B, this will be a little bit different. This will be inverse because again, we're dividing by the variable. So if we take -4 and divide 4 by -4, we get -1. When I divide 4 by -3, I'm going to get a decimal. So just for now, I'm just going to skip it. We can plot it, obviously, but I'm just going to skip it. 4 divided by -2, that's going to be -2. 4 divided by -1, that's going to be -4. So notice that my numbers are getting bigger, but they're still negative, so we're getting bigger negative numbers. Now here, the interesting thing is when you go to substitute in 0, 4 divided by 0 is undefined. Can't do it. It doesn't exist. And then 1, 4 divided by 1, that'll be 4. 4 divided by 2 is 2. 4 divided by 3, that gives us a decimal, so I'm just going to skip it for now. And 4 divided by 4 is 1. Now, I'm not saying you should skip the decimals on your table of values. I'm trying to save a little bit of time here. And we've got plenty of points that we can plot. We've got 3 other points that we can plot so we can see the shape of our graph. So I'm going to start at -4, -1. I'm going to go to -2, -2, and then -1, 1, 2, 3, 4, -4. So those were the 3 points that I had. And they're going to form this curved line. Now it's going to get close to the x and y axes, but it's never going to touch the x and y axes. So those are kind of like electric fences, okay, where the graph is going to get close to them, but never touch them. Now you don't have to draw in these dashed lines. I'm just doing that just to emphasize that the graph is going to get close to those axes, but never touch them. And then if we go to our positive values here, we'll have 1, 4, 2, 2, and then 4, 1. So again, we get that other curve, and it gets close to the axes, but it never touches them. So as we keep getting smaller and smaller numbers here between 0 and 1, we're going to get more decimals that'll be closer and closer to 0, but never actually equal to 0. And same thing over here. As I pick other values that are further out on the x-axis, I'm going to get small decimals that are going to be between 0 and 1, but they're never actually going to equal 0. So again, I'm never going to touch that axis. So these inverse variation graphs are going to look like this, where they have these curves that are either in the first and the third quadrant or the second and the fourth. And you can have ones that look, let's say we're going to have one in the first and the third, or we could have one that's in the second and the fourth. You can have graphs where they're in the first and the second, so I think those kind of look like a little volcano because it kind of opens up. And you can have ones that are in the third and the fourth, and I like to call those a tornado because they kind of open down, so it looks like a tornado. So you can have those as well. But for our purposes, I think they're all going to be in the first and the third or the second and the fourth quadrants. So again, this is just a visual way to notice the difference between direct and inverse variation. And again, we get a straight line here because we're multiplying for direct, and we get those curved two-part graphs because we're dividing by a variable. And for our last example, this is a word problem, so this is more of an application type problem. You'll see some of these in your homework as well. And here it says the volume of a gas at a constant temperature varies inversely. So right away they're telling you what equation you're supposed to be using. So it says the volume of a gas at a constant temperature varies inversely with the pressure. So if you remember from your English skills, this of a gas and at a constant temperature, those are just prepositional phrases, so we don't need to worry about them. Okay, we want to look for our subjects here. We've got the volume varies inversely with the pressure. Okay, so that's telling me how I need to set up my equation. So instead of using the y equals k times x for inverse variation, I'm going to make my first variable a v for the volume, and I'm going to make my second variable a p for the pressure. So that it goes in order here. Instead of y and x, I'm going to use v and p. So it goes in the same order as y and x. So this is the equation that I'm going to be using in the rest of the problem now. So that first sentence should tell you if you're using the direct or the inverse variation equation, and then you can substitute in the variables for the problem. Okay, now the next sentence says when the volume is 100 cubic inches, the pressure is 25 pounds per cubic inch. So that's telling me the values I'm going to substitute in for V and P. So again, I'm going to write my equation, V equals K over P. Now this is just like we did in example 3. The volume is 100, K stays K, and my pressure is 25. So they told me the values for the volume and the pressure, so I just substituted those in. Now I'm going to solve for K, so I'm going to multiply by 25. So I'll get 2500 equals K. And then I'll be able to rewrite my equation. So V equals 2500 over P. So that's just like what we did in example 3. They gave us the values and we substituted them in and we wrote the equation after we solved for K. But now I've got one more step. It says find the pressure when the volume is 825 cubic inches. So I'm going to substitute in the 825 for the volume. I'm going to leave my 2500 for K, and then I'm going to solve for P. Now, the way we solve for P is, since we're dividing by P, I want to get rid of that dividing, so I'm going to multiply both sides by P. Well, that's going to cancel the P's out of this side, but then I still have a P over here. I have 825 times P now. So now to solve all the way for P, I have to divide by 825. Now this is the long way to go through this process. And once I rewrite it here, I'll show you the shortcut. Now there's no shame in doing the long process if you forget the shortcut. But notice that with my original equation, I'll box it in here. This was my original equation after I substituted everything in. And this equation here, the 2500 and the 2500, they stay in the same spot. But the P and the 825, they flip-flop. So that's the shortcut. So if you want to write your equation and then go directly to this when you're solving for a variable that's in the denominator, then that's totally fine. Okay? But then if I actually finish and divide this out, I'll get 3.03. Now the pressure, let's see. The pressure was measured in pounds per cubic inch. So we would say that this is pounds per cubic inch. So LB is the abbreviation for pounds, and then if I do an inch cubed, that's a cubic inch. So that's the correct label on my answer there, pounds per cubic inch. Or you could write it out in words like they did with the word problem. So again, this type of a problem will tell you the equation that you need to use when it says varies directly or varies inversely. And then they'll also tell you the variables that you need to substitute in for y and x. You're going to be solving for k and rewriting your equation, just like we did earlier. And then it's going to take it a step further. So this last part here, this is the new part. So they're going to tell you another value to substitute in, and you're going to solve for the other variable. But you should have no trouble with that. The issue is that there's lots of steps. Okay, but I've color-coded them here, and you have this example to look back at. So as you're practicing the homework, oops, I think the homework is at the bottom here. So as you're practicing this homework, definitely show your work, reference your notes, and if you have any questions, come on in and see me before school.